Yes, hello class. This is the video for section 3.1. So we're starting chapter 3 this week and then continue next week and then the week after that. So in this chapter, we talked about certain rules of differentiation, or you can say rules of derivatives. And so 3.1, we talk about the rules of polynomials and exponential functions. If you have these, how do you differentiate them? Okay. And again, you must know these rules. You're not going to write the rules down for your exams or quizzes. You must know them. And the way to know them is to use them. Okay. As many as times as possible because you have to master it. Okay. All right. So in this video, after you finish this, you should be able to use basic rules of differentiation to find derivative of polynomial functions and find derivative of exponential functions with special case with base is what when the base is e. Now, I just want to mention that just as humans are governed by rules, so is finding derivatives of functions in calculus. Now, obey these rules and you'll be happy. If you don't use them appropriately, you're going to get the answer wrong. That's what I mean by obey and you'll be happy. All right. The first rule we want to talk about is what? The constant function rule. Okay. And then a constant function rule, when you have a constant function, you know that when you draw the graph of this function, it is what? It's a horizontal line. Okay. So this line is your y is equal to c, or f of x is equal to c. All right. So that is the line, or that's a graph for that function. Now, what's the derivative of that? Well, if we use the section 2.8 definition for derivative of function or derivative as a function, then we say well, the limit h goes towards 0, f of x plus h minus f of x divided by what h. Now, because the function is c, you're going to have c minus c, and the numerator will be 0. So you have 0 over h, which is going to be what? So when you take the limit, h goes to 0 of this, it's going to be what? 0. So it means that when you differentiate a constant function for any number, you always get what? You will get 0. Okay, so that's the first rule. The second rule is what we call the what? The power rule. And then the power rule for specific for integers, but I'm extending it to real numbers. Now, if n is a real number, then the derivative of a function, okay, when you have x raised to n, when you use this Leibniz notation, if you take this limit, what you do is that the exponent comes to the front, and then it is x raised to what? N minus 1. Subtract 1 from that. So where n is what? Is a real number. So it could be an integer, it could be a fraction, it could be even a square root of irrational number, whatever number it is. Okay? All right. So that is the rule for that. For example, if I want to differentiate this expression, okay, if this raised to the 6, then using this rule, it's going to go n is 6, so 6 times x raised to what? 6 minus 1. So the answer will be 6x to the what? To the 5th. Okay, so I don't have to use a definition as we did in chapter 2. We use these rules to do that. And it makes life easier, frankly speaking. All right. Then the other rule that we have is the what we call the constant multiple of what? A function. So if you have a function f of x is equal to c times a certain f of x, then this is what we get. Okay, so derivative of a function like that, okay, where c is a constant, you bring the c outside, okay, and then you differentiate the function, and after that you multiply. So that is the third rule. Okay, then the next rule is the sum and the difference. So if I have something like say x squared plus 2x, how do I differentiate that? Okay, remember we did the 4x minus x squared when we use the definition in 2.8. We're able to use the definition to find this derivative. But since I know these rules, I don't need to use that. But I can use this as sum, or the difference of two expressions. All right. So if you have two functions that are differentiable, okay, then the sum, okay, then means that differentiate them individually and then add them, okay? And then the difference is that when you have f of x minus g of x, just differentiate them individually and then subtract them. So this is the difference part, okay? Now these are, so that's the sum, and that's the difference, okay? All right, now we want to apply this to certain functions here. So we want to differentiate the following using the previous rules, the 4 rules that we just talked about. Now notice that e to the 5 is a constant, okay? This is constant. And so the derivative of that, if I differentiate this with respect to what? Respect to x, this is going to be what? 0. Okay, now if we want to differentiate this, what is f prime? This is the derivative of what? The operator of f of x, okay, which is the same as what? F prime of x. In this case will be 3x raised to what? 3 minus 1, which will give us what? 3x what? X squared. Okay, remember we use the definition to differentiate and find f prime in section what? 2.8, I believe. Yeah. Now, this is exercise number 6. The next one, that if you want to differentiate, you know, this is a trinomial, so it has 3 terms there. So we are going to use the sum and the difference, because between the first two, that's a minus, so that's a difference, and that's the sum. And therefore, in this case, f prime of x, which is actually the x of what? F of x, okay, is equal to, all right, you have 7 over 4, then the 2 will be what? Come in front, and x to what? 2 minus 1, okay, and you have 3, the x is raised to 1, so that is 1 times x to the 1 minus 1, okay, and then this is plus as a constant, okay, or let me do it this way, okay, it's the same thing. I'm going to find the dx of 7 over 4 x squared minus dx of 3x, then plus dx of what? 12. Now I'm showing this way, but as we keep going, I'm not going to spread it out like that. I can differentiate without have to what? Put the operators on each of the terms like that. So this would be what? 7 over 4 times 2 times x to the what? 2 minus 1. Using the power rule, the minus, you bring the 3 outside and you differentiate this. If you differentiate x, what do we get? Then plus, if you differentiate a constant, we know that's going to be 0. And so if we simplify this, this would be what? 7 over 4 times 2x. Now 3, if we differentiate x, okay, this would be 1, and then x raised to 1 minus 1, okay, plus 0 there. So that is going to be what? 7 over 2x minus 3, because we have 3 to be 0. We have x raised to 0, that is 1. So 1 times 1, that is 3. So this will be your answer to that. Okay, now for this g of x, we want to write this as what? 2x raised to what? Negative 1. Okay, so what is my g prime of x? Okay, if I use the power rule, which will be what? 2 times, there's a minus 1, x raised to minus 1, okay, then minus what we call, we subtract 1 from the what? The exponent. And so that is going to be what? Minus 2 x raised to what? Negative 2, which is the same as what? Negative 2 over what? X squared. Okay, now let me keep going and say, let's do for second derivative of what? F of x. Okay, so if I have this, okay, g of x is, okay, let's write here. My g of x, g prime of x is negative 2x to the negative 2. So if I differentiate that again, okay, g prime prime of x of this guy, which is what? The d dx of this expression minus 2x to the negative 2, which will give us minus 2, then negative 2 times x raised to negative 2 minus 1. So that gives us what? 4 times x to the negative 3, which is the same as 4 over what? X to the what? X to the negative 3. So it means that when the exponent, okay, when you write the exponent is negative, okay, it ends up increasing when it goes to the denominator. Because it was originally it was minus 1, then becomes what? Negative positive 2. That's a square here. Now, if you differentiate this, negative 2 became what? Negative positive 3. Yeah. So if it is dividing, then the exponent what? Increases like that. All right. Now, let's talk about the derivative of what? Exponential function. I have some other examples before that. Now, this is exercise number 10 in the textbook. So if you, to differentiate this, please, I know some of you thinking, oh, I'm going to use the power rule, the product rule, which will come to that in section 3.2. But for now, what we do is that we need to expand this. Okay, so if I expand this, I have for 3u squared plus 6u minus u minus 2. Before I differentiate, so I get 3u squared plus 5u minus 2. And this is my f of u. So what is f prime of u? Okay, the 2 times that is will be 3 times 2, and then u raised to what? 2 minus 1 plus, let's just be 5, and then this is u, 1 minus 1, then minus was 0. So that's going to be 6. There's a 2 times 3, which is what? 6. Then u 2 minus 1, which is 1. Then plus what? 5 u to the 0. And that gives me 6u plus what? Plus 5. Okay. For exercise number 23, you see that there's a denominator here, which is square root of x. So what we do is that we're going to spread it over the numerator as this. So we're going to write a y as what? X squared over square root of x plus 4x over square root of x plus 3 over square root of x. Now, that gives me your y now is what? Going to simplify each of the terms. You have x squared times square root of x. So it will be what? It will be x squared times x raised to negative 1/2 plus 4x times x raised to negative 1/2. Then plus what? 3 times x raised to negative 1. Okay, so let's simplify that. You have this will be x raised to 3/2, because 2 minus half is 1/1/2, which is that. Then this will be plus 4x raised to 1/2, then plus 3x to negative 1/2. So now this is my y. If I differentiate each of them, so what is your y prime? Or which is the same as dy over what? Dx. Okay, differentiate each of the terms. Okay, so if I differentiate each of the terms, that is x to 3/2 plus the dx of 4x to the 1/2, then plus the derivative of what? 3 times x raised to the negative 1/2. Okay, so this will be 3 over 2, then x raised to what? 3 over 2 minus 1, plus, we got 4, and then we have 1/2 x to the 1/2 minus 1, then plus, we have for 3 times negative 1/2, okay, x with the minus 1/2 minus 1. So using the power rule on each of them, power rule with the constant multiple of what function. So the first one will be 3/2 x raised to 1/2. Okay, then we have plus 2 to 4 is what? 2. We have 2 x raised to negative 1/2 because we have half minus 1 is negative 1/2. And then this will give us minus, because 3 times negative 1/2 is 3/2, negative 1/2, and the x raised to minus 3. Okay, so your final answer will be 3 over 2 square root of x, because x raised to 1/2 is, sorry, that's just, it won't be positive. So it will be 3/2 times square root of x, then plus 2 over the square root of x, and then over here we have minus 3 over 2 times x raised to 3/1/2. So this will be your final of your answer for that. Okay. All right. So we've done about what 6, 7 examples using those rules. There's more we'll do on Wednesday when we meet. Okay. All right. Now let's go to finding the derivative of exponential functions. So let's consider the exponential function f of x equal to 2 raised to x. We want to find what f prime of that. So we want to use the definition to do that, and then we will simplify this. Okay. So now we have what is f prime of what? F prime of x. This is the limit h goes towards 0 using the definition. Okay. F of what? X plus h minus f of x divided by what? H. So what is that? This is the limit h goes towards 0, and they have 2 x plus h minus 2 to the x over what? Over h. All right, now notice that the numerator, we can factor 2 raised to what? 2 raised to x from that, because this is how it looks. You should view it like this: 2 to the x times 2 to the h. Okay, that's why we got 2 raised to x plus h. Then minus 2 to the x over what? Over h, which will give us the limit. Okay, the limit h goes to 0. We factor 2 to the x out. Okay, then we have what? 2 to the h minus 1 over what? Over h. All right, now this factor doesn't depend on what? H, so we can bring it outside and write it as 2 to the x, then the limit h goes to 0 of what? 2 to the h minus 1 over what? Over h. So the question is that what does this value, what is this value? What does this value equal? Okay, what does that equal? So we're going to use table to find these values when h is what? Is small. Okay, so in the next slide. So if you look at the table here, we are taking values of h. That's the same expression that the 2 to the h minus 1 over h. So when h is 0.1, that is the value. When h is 0.01, that is the value. When h is 0.001, it is what? 0.6932. Okay. So when we evaluate this, all right, that's the f prime of what? When at x equal to what? It's equal to 0. For this expression, it's approximately equal to this. In other words, when I take this expression and evaluate it at x equal to 0, I get that value. In fact, therefore, f prime of x is approximately 2 to the x times what? That value. Okay, now you will notice that this value is actually the natural log of what? Natural log of 2. Now, if you have a calculator, you can check natural log of 2 to 6 decimal places is given is that value. Okay, so generally, okay, generally, we will come back to this. We'll come back to this. But generally, if you have a function, an exponential function b, where the base is what? Any, could be 3, 4, 5, or 6, or even e, okay, then the f prime is given by what? The b, the same function, times the natural log of what? The base. Okay, we'll come back. So what we have here is that if I differentiate the dx of 2 to the x, okay, then this is actually what? 2 to the x times what? Natural log of what? Natural log of 2. If we differentiate this function 3 to the x, then that would be what? 3 to the x, the same, times natural log of what? Natural log of the base, which is what? Which is 3. Okay, a special case, okay, and this is what I've just explained here. All right, now you will notice that when you the derivative of x to that is approximately, when x is equal to 0, it's approximately that. Okay, and that is from the limit for the 3, h goes to 0 of which we call it, that will be 3 to the h minus 1 over h. And this value is actually equal to that. Okay, well, so what is happening is that depending on what the your basis, you get what I explained, that you take natural log of a b to the x, you get b to the x times the, natural log of what? Of that, the base. All right, so a special case is when you have what? The base is what? Is e. Okay, so the base is e. When you express this, this is equal to what? Is equal to 1, as explained here. Okay, so therefore, when we differentiate what? A function e to the x, remember you get the same e to the x times what? Natural log of e, because the base is e, and the natural log of e is equal to 1. Therefore, this is equal to e to the x. And so when you differentiate e to the x, you get the same. Okay, the same function. That's why it is like that. Now, let's do one example and we'll do more example later. Right, so we are given this function, okay? And let's rewrite the function carefully. We got 3 times e to the x plus 4 divided by, this is a cube root, so that is x raised to 1/3. X raised to 1/3, okay? Which is the same as what? 3e to the x plus 4 x raised to negative 1/3. So then if I find dx of this, of the y, okay, which is find the derivative of each of the terms and then add them together, e to the x plus the derivative of that 4 times my negative 1/3. Okay, so if you have a constant, then you bring it outside times the derivative of what? The function e to the x. Okay, so bring the 4 outside and then multiply by the derivative of 4x to the negative 1/3. So this will give me 3 times, if you differentiate e to the x, you get the same thing, e to the x plus 4. Now if I differentiate this, I get negative the exponent negative 1/3 times x raised to minus 1/3 minus 1. Okay, so then this will be what, 3e to the x, because 4 times negative, that will be minus 4 over what, 3, and then you have x raised to 1/3 minus 1 will be minus what, 4/3. Okay, so your answer to this will be what? There's a 1 there. Okay, the answer to that is your dy dx, which is the same as y prime, is equal to what? 3 e to the x, then minus 4 over 3 times x to the what? 4 over what? So that is your what? That's your answer. Okay, so in this section, we look at certain rules. We look at the constant rule, the power rule, the constant multiple of a function, and then we have the sum and the difference, and then also exponential functions. And then we'll consider more in the subsequent sections in chapter 3. I'll see you later then. Thank you.